Hi, my name is Jacob Pitzenberger, and in this video, I will be presenting my face detection software, which consists of a Tkinter GUI that allows users to perform facial detection over image and video files, in addition to real-time video streams from both internal webcam feeds, USB webcam feeds, and Wi-Fi camera feeds. Now, I'd like to walk you through my modules and give a brief description of how I structured my program, and then I will demonstrate its use over these types of media. Now, looking in my IDE, you can see that under my project folder, there is a package and our face detection software.py file, which is our entry point to our application. Now, within the package, we have a data files folder, which contains our HAR frontal face cascade. In addition to the data files folder, we also have modules for our GUI class, our directory manager class, in addition to our two face detector classes, the frontal face detector and the mesh face detector. We will start in our face detection software.py module, which is the entry point to this application. Now, in this module, we import from our GUI module the GUI class. And this module has a dunder main method, which we use a try except block to handle any exceptions. And in the try block, we initialize our GUI, specifying the version of the face detector to use. After initializing this, we call the GUI's run application method to begin our program. So now that we've explained our entry point file, which is the face detection software.py file, we're going to take a look into the package and go through the imports, with the first import being our GUI class. So our GUI class is what imports all of our other classes from our package. These include our two detector classes, each in their own module, and a directory manager, which is also in its own module. Now, we'll go into explaining these further as we move through our imports. But for now, let's move on to our GUI class. Our GUI class first starts with defining some constants. These constants are for formatting our buttons, its text, and its colors. Now, on to the GUI's initialization. Our GUI initializes first our directory manager class imported from our package. Now, directory manager needs to be initialized first so that it can create the directories for storing our detection files, whether it be image, video, or real-time feed detections. Now that we have our file structure set up, it's time to specify the version of our detector to initialize. So we get this from our argument. If the user specifies they want to use version 1, then we initialize our frontal face detector class. And if the version is 2, then we'll initialize our face mesh detector class. After this, our initialization consists of initializing our GUI's elements, which include the root window, a title label, and then buttons for the various features of our GUI. The last thing to note here is status label. This status label is what handles informing the user whether or not an image file or a video file has been successfully processed for detections. So if a user clicks the image or videos button, they'll be brought to their file explorer where they can select an image or video file in which this software then runs detections over. After it is done processing, this status label informs the user that the file was successfully processed for detections. At this point, a user can use the Files button to then go into their directories and open these files. Now, let's move on through the methods. The first method we see is our show help method. This is accessed using the help button on the GUI. Now, this just displays some text informing the user on how to use the software. There's nothing else to say here except for that this runs in its own Tkinter main loop and its own window until the window is destroyed. This doesn't affect our main menu of the GUI. It is still appearing on the user's screen so that they can continue to use its functions. Now, the next methods of the GUI class we're going to look at handle with opening files and the file explorer. So the first one we have here is open with default player. This allows users, well, this doesn't do anything for the user directly. It is actually used in the following method, which is open file with default player. So open with default player, this method simply determines if the file path belongs to a Windows or a Linux system, and it handles opening the default application media player for that system. Now, like I said, this is used in the method open file with default player. So this method calls another method below open file explorer, and it gets the file path for the file selected by the user there. Now, then we use our open with default player to allow the user to view their media using their system's default media player. With that being said, our open file explorer is another static method. It opens the file explorer for the user in a root directory called face detection software. Now, this root directory also then contains directories for image detections, video detections, or camera feed detections. And these directories all store videos, images that were processed for facial detections through use of this software. And they are stored in their respective directories, whether it's a video file post-processed, an image file post-processed, or a real-time feed that was processed during its real-time video capture. Now, moving down below this, we see a clear status label. This simply clears the status label after a success message has been displayed. Now, past these methods, we have our run application method. This is what we call in our entry point to the software after initializing our GUI class. Now, we use exception handling throughout all of my code. So, just like so, in our run application method, we use try, except, and finally blocks. We try to pack all of our GUI's elements to the root window and then call the Tkinter main loop as our main loop for the program. Now, if there's any exceptions, we handle this with a message to the console. And finally, after all said and done, we call a cleanup method, which we'll look at last. So past these methods, we have our different methods for detection. We're not going to go into the specifics of each method as they handle the type feed differently slightly. But I would like to point out that each detection does save the file in which detections were made over, whether it be an image or video file or a real-time capture that is stored in a video file. These will all be stored in our directories previously mentioned with timestamps for the time in which detections were made. So we're going to skip through these and we'll see their use for the different types of video sources we have available. So moving past these, we have one more method to cover, which is our cleanup method, which you saw in our run app method. This is called in our finally block, and this just ensures that our root window is quitted out of, and we exit using system.exit to ensure that all of our resources are properly dealt with. Okay, so now we've explained our GUI class, which we import in our face detection software.py entry point file. Now, within our GUI class, the first other class we initialized as a part of it was our directory manager. So let's look at that. Here we have our directory manager.py file. This module contains our directory manager class. Now, within this class's initialization, we initialize the path to the root directory, which is titled face detection software. Now, after this, we specify the paths to the different locations of our different types of media detections. This includes a recordings directory, which is under our face detection software root directory, and as are our videos directory and our image directory. Now, for this class, we take these directories and we store them in a list of directories that belong to our directory manager. Now, after initializing it in such a way, we have one method called create directories. This creates all of these directories in the initialization if they do not exist, which is why we wrap them in a list. Now, with this handling all of our directory work, we can very easily edit or change our file paths and basically implement this software in a variety of cases for a variety of different storage purposes. We now have two modules left in our package to look at, and that is our two detector modules. We're going to look next at this frontal face detector module, which contains our frontal face detector class. Now, this class has some constants for drawing text and rectangles on our video feeds. or images. Now, in the initialization, we get the current file directory we're working under. This is dependent on which type of media we are performing detections over. After this, we defined a path to our HAR Cascade file, which is located in our packages data files folder. After this, we simply create a cascade by passing the cascade path into the cv2.cascade classifier method. Now, our frontal face detector contains one method for detecting faces. It uses a try catch block to convert the frame. Well, let me start by saying that this method takes in a frame object, which is a numpy.nd array. And with this frame, it converts it to grayscale to speed up our detections. And then we get a numpy array using our HAR Cascades detect multi-scale method. And we pass in our grayscale image, a scale factor, and a minimum neighbors parameter. After this, we go through the faces detected and we get the dimensions to draw a rectangle around their face on the frame. After this, we go ahead and we get the face count, which is the number of faces that we detected with our HAR Cascade. And we go ahead and we put this text on the screen so that we can see how many faces are currently being detected in each frame. Past this, we simply print the count to our console just so we can see it through our development. Now, we also handle this with exception handling, and we will print if there's an error that occurs. It's now time for us to look at the last module in our package, which includes our face mesh detector class. Now, this face mesh detector class also initializes some constants for drawing to our frames. Past this, in its initialization, we have parameters, which are typically used to initialize the Google MediaPipe's face mesh model. With that being said, I will keep the details from this conversation. I will go into the details of saying that in this initialization, we initialize the MediaPipe drawing utilities and face mesh model with these lines here. Now, unlike our HAR Cascade, we use two methods in this class. So the first method below is for detecting our faces. This method takes in a frame, which is a numpy.nd array as well, and we process this slightly different in the way handled by the Google MediaPipe's face mesh model. So we also convert our image, but for this reason, we do it to RGB because of OpenCV's BGR color space, and we don't want that in our displayed output. After this, we're going to process the frames with our model, and then we loop through any results found, and we get the bounding box. And we define this then here. This is worth pointing out as self.draw bounding boxes. So this draws our bounding boxes to the frame using another method, which is our only other class method for the face mesh detector. This drawing bounding box method takes in the frame as well and the face landmarks. So it needs our landmarks so that it can get the bounding box coordinates in order to draw a rectangle around the face, in which is made up of key points that are not a perfect rectangle. In fact, they're curved, for lack of better words. Now, without going into details, this method computes those four coordinates and it draws the rectangle in our face detection method. Now, like our HAR Cascade, we also do a face count and put the text to the screen and in the console. Thanks for watching my code walkthrough on my face detection software. If you're interested in seeing what the results are of this software, I would like to point you to my demonstration videos, where I demonstrate version 1 with our Viola-Jones HAR frontal face cascade used for facial detections. Or in this other demo video, where we use version 2, the Google MediaPipe face mesh model to perform our detections. Thank you again, and have a great day.